Let's take a look at this example. We're supposed to find the current I. So this is this current. We're supposed to find I1, I2, and I3. Please notice that we use the conventional current flow, so it means that the current flows from the higher potential to the lower potential. Okay, so 18 is the highest potential in the circuit, so we have also ground, which has 0 volts, and we have also the voltage negative 5 volts, which is the lowest potential, right? So how the current is going to flow? Okay, so the current is going to always flow from the highest potential to the lowest potential according to the conventional current flow. So what we are going to write first? I'm going to write that my voltage source 1 is equal 18 volts. And my voltage source 2 is equal negative 5 volts. Okay, so let me just find the current which will flow through, let's say, resistor R1. Resistor R1 is connected directly to the voltage source 1. Okay, so I have like voltage source 1 connected directly to resistor R1. So I can say that V1 is equal voltage source 1, right? And this is equal 18 volts. Now, so if I want to find the current which goes through this resistor, okay, so I can simply write that I1 is equal V1 over R1. V1 is equal 18 volts over R1, which is equal 4 kilo ohms. This is equal 18 divided by 4 exponent 3. This is equal 4.5 milliamps. Okay, and current flows from the higher potential to the lower potential. So my current is going to go in this direction. This is going to be my I1 because 18 is greater than 0. This is 0 volt. Okay, ground has always 0 volts. So I found I1. Next, I'm supposed to find I2. Please notice that at this point I got 18 volts. Let me call this point A. And this is my point B. At point B I have negative 5 volts. So voltage across resistor R2, V2, is nothing else just the voltage VAB. So if you want to find voltage across this resistor, simply subtract VA minus VB. VA is equal what? 18 volts minus negative 5 volts. This is equal 23 volts. Okay, so voltage across resistor 2 is 23 volts. So if I want to find the current I2 is equal V2 over R2. V2 is equal 23 volts divided by R2, 2 kilo ohms. So I have 23 divided by 2 exponents 3 equals 11.5 milliamps. Okay, so this is current which will go through resistor R2. And someone is going to ask in which direction this current is going to flow. Always from the higher potential to the lower potential. Okay, so because we use conventional current flow, I'm going to say that current goes from point A to point B. So this is my I2. Next, I'm supposed to find current I3. I3 is the current which will flow through this resistor. Okay, so I3 is equal V3 over R3. Voltage across resistor R3, right, is simply voltage from this point to ground. Okay, and what I got? Negative 5 volts. Negative 5 volts is connected directly to this resistor. Okay, so this is like a voltage source over here, connected in this way by the negative terminal and connected to the ground. So it means that this voltage source is connected directly across this resistor because these two grounds are connected together, right? So I have negative 5 volts across this resistor. That's why I'm going to write over here negative 5 volts over 8 kilo ohms. So this is equal 5 negative divided by 8 exponent 3 equals negative 625 microamps. Okay, so this is the current. This is the current which will flow from the higher potential to the lower potential, like always, and it's going to go in this direction. From the higher potential, 0 is greater than negative 5, so current is going to go in this way. So next we're supposed to find current I. This current is going to split into two currents, I1 and I2. So if you want to find I, you have to use KCL, simply add these two currents together. So I is equal I1 plus I2, where I1 is equal 4.5 milliamps plus I2, which is equal 11.5 milliamps. This is equal 4.5 exponent 3 negative plus 11.5 exponent 3 negative equals 16 milliamps. 16 milliamps. So we found I, we found I1, I2, and I3. We can say that the problem is solved.